And that brings us to AES. AES was developed in the 1990s by an open competition run by the National Institute of Standards and Technology. So still a government entity, but with a very different mission than the NSA. And the winner ended up being a variant of an algorithm called Rheindahl. AES has 128-bit block with 128, 192, or 256-bit keys, but even now it's mostly used with 128-bit keys. Internally, AES has some of the same structure as DES. There is a key schedule that's generated from the key, but in the case of AES, there are only 11, 13, or 15 elements in the key schedule, depending on whether you have 128, 192, or a 256-bit key. No matter how big the key is, each element of the key schedule is going to be 128 bits. AES also uses a reversible mixing function R instead of the one-wave function F and the Feistel structure that went with that. But it's still the same idea of mixing elements of the key schedule with the plain text and mixtures derived from the plain text. Here is DES and AES next to each other. AES is not usually described this way, but I'm drawing it in a DES-like way so that you can see the similarity. Skipping the first step of AES and the last step because they're a little bit different, the steps in between involve this reversible function R, which takes our current mixture and an element from the key schedule and mixes it together. And because this is reversible, that means that decoding is going to straightforwardly go the other way. We don't have the two halves and the Feistel structure that mixes those halves. The setup is a little bit different in that there's no R that's used to get from our original plain text into the first mixture. Instead, we just XOR the first key. And that's because this reversible function doesn't really do much useful in that first step. The last round also uses a different function. It uses almost the same R, but it's a slightly simplified R because the last thing that the usual R does is, again, too easy to reverse and not really useful. And so these little tweaks just make the algorithm slightly faster.